pues a lo que hemos venido, ¿cierto? ¿Quién es la persona que va a venir hoy día? ¿No? Es, pues acá lo voy a poner, ahí está. Danilo Pocha es la persona que nos va a acompañar hoy día desde Italia. Pues él es el Chief Evangelist de, ¿no?, Europa, Middle East y África de AWS. Sí, toda esa enorme zona, él es el principal evangelizador en AWS. Digamos que si Jeff Barr es el Chief Evangelist y Vice President, después está Danilo Pocha. Y pues vamos a tener el honor de tenerlo junto con nosotros. Es más, ya está junto con nosotros, así que lo voy a invitar y empecemos la conversación. ¿Qué dicen, muchachos? ¿No? Vamos a ver. Hi, Danilo.
Hi. Hola to todos. That's all my Spanish, unfortunately. But
no, yeah. That's okay. That's great Spanish. A little bit.
Thank you.
That's good. Nice t-shirt. Yeah, nice shirt.
Thank you. We just got this in the developer evangelist team, and each of these has his own figure, its own character. So that's supposed to be me.
Yeah, it seems to be like the gift that Sebastian Stockmark.
Yeah. You just got this. Got them this week, so we are all excited. We got this box full of shirts, t-shirts, and stuff.
That's great. And we are honored to have you right here, Danilo, at least virtually, but it's awesome that you can share with us a lot of your expertise in serverless that you're going to talk us today, this afternoon. So, Danilo, please, can you share with everybody a little bit about yourself, a little bit about how great, I think it's great, your role is in AWS, and then you can start your presentation, I think.
Of course. So in my role as evangelist, I really try to help developers, builders everywhere in the world, as you can see today, to understand the possibilities, what they can achieve in a much easier way using AWS, so that they can really bring their ideas to life. And that's really the theme of my session today, where I will go into some of the new stuff that we launched for serverless.
Wow, that's great. And that's the main thing that you're going to talk about today, right? About what we can do with serverless, what all the possibilities are to play with serverless in 2021. So furthermore, I will let you start your presentation, and please, this audience is yours, this audience is for you, and I hope you have a great time here.
Thank you. So let's see. Okay, you can see the slides. Perfect. So first of all, again, I'm really humbled to be here. It's an amazing agenda, and you really kickstart the year with an amazing event. So I hope this will serve as an introduction to all the other sessions that you are having today. And the idea of this session really starts from an event that just finished. So this is an important period for us in AWS, because AWS reInvent, our yearly conference, when we launch most of the new stuff, has just finished. This year it was a different event. It was completely free and completely remote. It lasted most of December and a few days in January. And during these few weeks, we launched many new features and many new tools. And in one way, I think of these tools as seeds that we're planting, seeds that at first they can seem small, but then they can help your idea grow and be built in a much easier way. And the idea is really that if you have an idea, you want to build something new, maybe you want to build a web mobile app, you should find the way to build this application in a faster and easier way, so that you can very quickly bring your idea in the hands of your possible customers and get a feedback and maybe change something and understand if this idea can work or not. For example, let's say that I want to build an application that can work with the videos that I record with my smartphone. And these videos can be maybe stored in the cloud and analyzed. Maybe I can get some information, like extract a description of what's in my video and create a textual description of my video. That's something that just a few years ago would be science fiction, and now it's something that you can relatively quickly build and put in production with very little cost if you start small and then you grow as your users grow. And to build so, you can use different techniques, but as you already saw at the beginning, I really am quite an advocate of serverless, because I think serverless architectures can really help you stay focused on the features that you want to build, and also can help you understand the security of the application that you're building, because each component has its own permissions, and also they can scale up and down depending on the real users that you might get. And a serverless application is very easy to work with, because it works this way. Something happens, so for example, a file has been uploaded, or a database is updated, or you receive an API call like, please, your mobile phone is asking, please do something. And this is an event that will trigger the execution of a serverless function, like a function that you can build with AWS Lambda. And this function is really your code, it's your business logic, and each function has its own permission. So it can read here, can only write there. So in this perspective, it can help you think about the security as you develop the application. And this function can scale up if you have many requests, or can scale down if you have few requests. And you only pay for what you use. You really pay for the execution time of your function and the number of invocations. And for example, we can build this application that I was mentioning, where I upload my videos to the cloud from my smartphone. I can store the videos, for example, in an S3 bucket. And this fires an event that can execute a Lambda function. This can be my analysis function that is using maybe some services that we provide, like Amazon Recognition, or it's using your own custom, maybe machine learning model to analyze the video and extract information from this video. Maybe you need to resize the video before analyzing the video, because this is often a necessary step. And then you extract information and you write for example, the object, the things that you find in this video in a database table, maybe using something like DynamoDB. And then now that you have the result, you can create an API, so that from the mobile phone, you can ask to an HTTP endpoint with security and authentication if you want. Can you describe to me the video that I just uploaded? And this fires another Lambda function that gets the results from the table and returns the result, maybe formatted as a descriptive text, or maybe in a schematic format, depending on what you need. And this is the simple architecture that can help you build what you need to do for this application. And here, only the Lambda function needs to be created. Everything else, the storage, the database, the API endpoint, everything is fully managed and can grow and shrink depending on the actual load. And maybe you can ask, hey, many of the functions that I have, many of the interaction that I have with my mobile app are very quick, very fast. They maybe take 10, 20 milliseconds. Is Lambda the right platform for this? Well, from a performance point of view, there's no issue. And recently at reInvent, we also improved the cost, because we reduced the building granularity for the duration from 100 milliseconds to 1 millisecond with no minimum. But that means that you only pay for the actual milliseconds your application is executed. So before, for example, if you were launching very fast functions like this one, where I extracted a log, the duration was slightly more than 27 milliseconds, we would round up to 100 milliseconds, and you would pay for 100 milliseconds. It's not a lot, but if you have maybe millions of invocation, it starts to notice the cost. Now you pay for the single millisecond. So this would be rounded up to 28 milliseconds. So it's less than 1/3 of what you would have paid before. So if you have many very small and fast interactions, Lambda is now much more cost effective, and it's a new use case that you can use more with serverless. On the opposite of the spectrum, you may have very dense and heavy phases, like when you want to analyze a video, a very high resolution video that you took with your smartphone, you need a lot of power. Is Lambda the right platform for that? Well, we recently increased more than 3 times the amount of memory that you can have when you execute a function, up to 10 gigabytes, and also more than 3 times the amount of CPU power that you have available in the execution environment of your function. It's now 6 virtual CPUs. And this means that now you can do much more. This is a nice graph that was shared with me on Twitter by a customer that was doing some tests with FFmpeg, that is an open source tool to resize video. And in this case, the video encoding that he was getting with Lambda with 10 gigabytes was almost the same as the one that he was taking with the MacBook Pro 16-inch brand new that he was having at home. So it was very, very fast. And of course, you have maybe a single MacBook Pro, but you can start hundreds of Lambda functions in parallel, and each one would have this power available for them. I also like this graph that is a little bit more tricky to understand, but it shows not only the advantage in power, but also in costs. So here I was using a machine learning tool that is called PyTorch. And I was testing the same Lambda function with different memory configuration that you see on the horizontal scale, from 1 gigabyte up to 10 gigabyte on your right. And the orange bars, they show the duration of the function depending on the memory. So more memory, more CPU, the duration goes down because there's more CPU, and this tool can use all the CPU power that was available. And you can see how the time is shrinking. So these functions are faster, and you normally provide a better customer experience. But what about cost? So costs are shown with the red line above, and the red line is showing the cost for 1 million of invocation. So you're in the 60s, $80 for 1 million of invocation. So if you think about it, it's not much. But what I find really interesting is that if we take these 2 points here, we see that we are exactly the same costs with 1 gigabyte and with 5 gigabyte, because since more memory, it's more costly. But since the functions are faster, you absorb the increasing cost by the faster function and the reduced duration. And in this case, you get the same cost, but the function is 5 times faster. So more memory, more CPU means that you can go faster without paying more. And I love this graph. And you may ask, okay, I like this, but I really want to go fast. How is the Lambda environment comparable to other environments? Well, we're trying to make it more powerful for you. So again, just before re:Invent, we give you access inside the Lambda environment to the AVX2 extension. This is an extension of the x86 CPU processor that allows you to execute some instructions in parallel. And the good news is that you don't need to change many times your application, but you can just use libraries and tools that can use this AVX2 extension for you, and you get the benefit. So this is a blog post that my colleague James Beswick wrote, where he's doing some tests with image resizing. That is a very common task for Lambda. In this case, it was building thumbnails using different algorithms like bilinear filter, bicubic filter. And he was doing this test without AVX, and then without changing the code of the application, it just switched the library with a new library that was using this AVX extension to execute CPU instructions in parallel. And we was getting a performance improvement of 30–40% without changing anything. And so this is faster, better customer experience. And as we saw before, since you pay by the millisecond, it's also 30–40% cheaper for you to run. Another aspect that is important if you want to build a complex application like the one that I was mentioning, where you want to process these large videos, is that you may need to use libraries, external modules, and you need to bring all these libraries as dependencies of your Lambda function. And in the past, this was not super easy. So now, to help you with that, we launched container image support. So it means that you can package your Lambda functions as container images, and then you have up to 10 gigabytes of sites for these container images. And so you can very easily bring your tools with your Lambda functions. And also, if you're used with container tools and container tooling, you can use the same experience with Lambda function with serverless architecture. So this is an example of the most simple Docker file. So this is the file that describes the creation of the container image for a Lambda function. So here we're using a public base image that we share using the new public Elastic Container registry that we provide. You can use Docker Hub if you prefer, but with the free tier of the ECR public, this is probably the tool you want to use. And Here we're just copying in this Docker file your source code, and then you can use npm, for example, for Node.js, or pip for Python, or any operating system command, and even compilers to add libraries and modules to your container image and bring it with you for the execution of your Lambda function. So this is much easier, especially if you're familiar with this tooling, and it can really help you create Lambda function that bring, for example, machine learning model and advanced analytics to the cloud. So if you start creating your application, one thing that I like of serverless is that you have all these small functions, like the one that we saw in the architectural diagram before. No, one was extracting information from the video, one was reading from the database. So you can create small function with a single purpose, but sometimes these functions start to be big because maybe you add functionality and you start to lose some of the speed. For example, if you want to add more features, you need to remember, oh, okay, well, I can change the code here because this part I know it very well, but you need to understand the whole function. So my suggestion is decompose large functions in smaller functions and use tools like AWS step functions to create a workflow that can be executed asynchronously. And now, this is new, also synchronously. So it means you can call a workflow, execute different Lambda function, and get the result back. And to show this is a blog post we're taking this architecture where you have an API gateway, so an API that you call, and this API, instead of having a large Lambda function interacting with different things like Amazon Comprehend to do sentiment analysis, or sending an email using Amazon SAS, store the information on a DynamoDB table, is having lots of small tasks decomposed, sometimes with a Lambda function, sometimes using directly step function syntax. You can have also different branches with choices, so that it's really clear from this architectural, from this workflow diagram, what's the purpose of each function. And in this way, you keep your software architecture easier, simpler, because each component is smaller and easier to understand and update in case you need to add new features. Another thing that I often get asked is, okay, now that I have all these Lambda functions in production, how can I understand exactly what they are doing in production, if they are working correctly in production? And here really the key word is observability. This is more than monitoring. It's really creating the tooling that helps you understand the flow, tracing all your invocations, or most of your invocations, to understand how things are working in production. This is a broad topic, so I'm not going to that deep here, but I would like to share two things. One is there is a global open initiative that is called Open Telemetry, and AWS is participating together with other companies. And I would suggest, if you're interested in observability and monitoring, look into this Open Telemetry initiative and see how this can really simplify the way you integrate your code and instrument your code to be observable. And also specifically for serverless, we launched within CloudWatch, our monitoring platform, Lambda Insights. And Lambda Insights, you can enable it and you can get many insights of how your function is working, depending on the duration, the memory use, the concurrent execution, how your function is costing over time. It can really give you much more information than the normal standard deployment, and you can enable it, use it for some time, and then disable, but it can really help you understand how your application is working in production. Another question that I got asked a lot is on the storage S3. So S3 is an object storage where you can store images and text files or whatever. And historically, this has always been described as eventually consistent because it's a globally distributed storage. And if you were to update an object for some time, you could still read the old version of an object. Now we changed that without any impact on performance. Now S3 is fully read after write consistent. And that means that with any throughput of reads and writes, if one client is writing something like, this is the color red, and then another client is updating the same object saying, no, the color is actually Ruby, then if you read it immediately, you already read Ruby from any client you use. So this can seem simple when you see it, but it really requires big changes in the backend, and it helps you use S3 more efficiently in your application to store data that can be updated often. Talking about data, security is also very important, and having your data, especially your customer information, encrypted is really important. And we make it easy with S3 because we can manage server-side encryption. But in the past, this could be costly because all the interaction between S3 and the key management service on AWS would create some additional cost. Now we reduce this cost up to 99% because instead of having many interaction between S3 and the key management service to get these encryption keys and process the data, now the S3 bucket can ask for an S3 bucket key that can use for processing all the data inside the bucket and keep this key for some time. It's not stored persistently on S3 because otherwise it would not be great from a security point of view, but it can be used for some time. This is reducing the interaction and also all the cost of using KMS. So server-side encryption is much cheaper than before. Talking about the database, many customers, especially on serverless, but especially when you care low latency and on-demand scalability, where you start with maybe very few throughput and then you want to grow, they want to use a NoSQL database like DynamoDB. But maybe they are not familiar with DynamoDB. Maybe they come from a relational database. They used to use Postgres or MySQL. To make it easier, just before an event, we launched a new feature of DynamoDB that is now compatible with SQL. You can use an SQL syntax to query, insert, update, and delete records, items from DynamoDB tables. And we integrated this also with a free tool that we have that is the NoSQL Workbench that you can download on your laptop or on your computer. And you can use this tool to experiment with the syntax. Like here, we can select use this select syntax with DynamoDB. So select from the music table the songs where this is the artist and this is the song title. And within the NoSQL Workbench, you can also use this syntax to generate the code for you for different programming languages so that you can create the code and then copy the code inside your application. It's much easier to use DynamoDB if you've never used before. Another important part is customer interaction. So if you want to add more features or you want to add customer support, one way to interact with your customer is to use a chat, but you can't chat with all your customers, especially if you have many of them. So chatbots are very common, where you can write in your native language and the computer can understand what's the meaning, and maybe for most of the requests, it can automatically do what you need. And then sometimes if the request is too complex, it can be passed to a human. And to work with chatbots, we have a platform that is called Amazon Lex. And for many years, it was English only. And more recently, we launched language support for many different languages. So French, Spanish, Italian, including the Canadian French and the Latin American Spanish flavors, and also German. Yeah. So you can now build chatbots with Lex, where you can write or speak using these languages, and you can get a response written or spoken. And you can also create, this is the new console for Amazon Lex that we just launched actually this week, where you can create very easily multi-language chatbots. For example, this is an example where you create a chatbot to reserve a car that you rent. So you want to rent a car. So you say in which town you want to pick up the car, which are the dates where you pick up the car and when you give it back. And this is an example of the conversation flow. I built it in English and also in Spanish in this case. It was actually an example because my Spanish would not be good enough, unfortunately. And also, when you build this kind of chatbots, you can interact also via using voice. You want to interact, to use the same chatbot also with maybe a traditional contact center where you call by phone and you want to speak with someone. And we have a platform. This comes from the Amazon retail experience, and it's called Amazon Connect. So in AWS, you can use Amazon Connect, and you can integrate Connect with people that is answering the phone, so traditional contact center operator, but you can also use Amazon Lex with all the languages are supported. And in this way, you can really create a contact center that is very much powerful, more than what you normally have. So this is an example of a reference architecture. You don't need to build this, but this is an example of what you can build. This. You start with a contact center using Amazon Connect. You can then plug in Amazon Lex with your chatbot, and you can interact using voice in the similar way. And then you can use machine learning services to add sentiment analysis, so you can transcribe all your calls into text and then maybe put everything into a standard language and then run sentiment analysis on this and see how customers are reacting and what are the topics that create more maybe emotions in your customer. And then you can use this information to create analytics and reporting that helps you understand how your contact center is working. Again, this is all serverless. All these tools that you see here, they don't need you to manage a server. You can really focus on the features that they had and the features that you want to build. So the idea here is really that all these tools, all these features that we are introducing really help you grow your ideas, build them, so that from a small plant, you can really build a huge tree and hopefully help and focus more on your customers. Thank you. So
Wow.
if you have any feedback, you can also use Twitter, and I will post my slides on Twitter. Sorry, I forgot to say that.
That's okay, Daniela. Thank you very much. Yeah, they were asking on the chat about the slides, so you're gonna share the slides afterwards.
Yeah. I will share it with you. So I don't know if you're planning to share the slides with the audience, and that's perfectly fine. But I will just after this session share these slides on Twitter.
Okay. I'm going to say it in Spanish for the chat. Si tienen alguna pregunta a Danilo, por favor, sería genial que la hagan ahora. ¿Sí? If anyone has a question. I have a very interesting question. I think would be great to hear. If what is the most challenging thing in serverless that maybe is going to be a trend in 2021? For example, I don't know. For example, observability, testing tools in serverless, machine learning in serverless. I don't know. Yesterday we have a lot of questions about involving machine learning workloads inside serverless applications, and most of the people said that serverless isn't ready yet to machine learning application, for example. What you can say about that in AWS, of course?
Yeah, you raise many very good points. So with serverless, every year, all these new features that we launch makes use cases easier to implement. And that's what I was also showing in this presentation. Focusing on machine learning, I think now with the new large functions that you can deploy and also with container image support, machine learning inference. So you create a model on a traditional platform. You can use SageMaker, you can use your own tool using PyTorch, TensorFlow. But when you have the model, deploy the model inside the function is much easier. So if your model is not requiring a GPU, so you are okay with the performance of a traditional CPU, maybe with AVX2 support, then this works great. Sometimes you run machine learning inference as asynchronously, like a batch operation. You upload some data and then you want to run machine learning on all the records. So in this case, probably the additional latency of not having a GPU may not be an issue for you. So in that case, serverless can help scale, because you can quickly stop 1,000 functions that process your data, and then they terminate after a few seconds, and you get your results very quickly without having to create a cluster or process a cluster and do things in that way. So definitely machine learning inference. For machine learning training, I showed in my reInvent session some use cases, for example, with tools with Python tools. You can do that with small model or using techniques like ensemble training, but it's a little bit more advanced.
Okay, I think the same. I think inference is it's more suitable for right now, right? Right now,
Yeah.
I think that we know right now in 2021 we will see something. Maybe a few things can change in serverless, but okay. The other the other thing that is going to wrap up the session is about what is the most challenging thing in serverless for this 2021.
So what is challenging? I would say that if I mentioned observability and the new OpenTelemetry initiative, I would say that if you start building something critical for your company using serverless, you have to think about observability, because otherwise, if you go in production, you don't have an observability strategy, then the first problem you will get, because everything can. We always say in AWS, everything can go wrong. No, everything can break. You need some tools to understand what is happening, what's the function that is low. Maybe it's a DynamoDB table that is under provision. Maybe it's a storage that is not configured correctly. So you need to have observability tools and observability strategy in place. So that's probably something that you have to think about, and it's very important. I also see a comment on in these critical periods, what we can do from C. Moreno, what we can do now to improve humanity. And this is actually something that I'm thinking about. So I would say that healthcare and it's an incredible hot topic. So if you're interested in healthcare and bioinformatics, this is something that is growing a lot, and I'm thinking about how we can do that easier with serverless. And also, we talk a lot about smart cities, but in general, how we can improve the life inside cities and communication now that we have to use this asynchronous ways, not these tools in the middle. So that's another topic that I think it's really important.
Yeah, of course. Very, very good. Very interesting questions, Carlos Moreno, right there. Thank you, C. Moreno. Okay, that's great. That's great, Danilo. I think we, thank you for this great presentation and this great wrap up. So what we can do in serverless in 2021. I think this 2021 will bring us with exciting news about serverless. And I don't know what to expect in serverless in AWS. So, but I have a few things in mind, crazy things that maybe can maybe be a next AWS service in the next months. So great. I think I will speak for a lot of people when I say that I prefer a lot of serverless applications instead of doing another things like containers or things like that. I think that serverless first is a thing that most of us may think as a principal choice when building applications. Mainly if they are building new applications, or they have the responsibility of creating new applications. They have the power of decide in which way we can build application. They have to think about serverless first, right?
Yeah, and I also like not to think as serverless as a complete alternative to containers or other technologies. You can easily mix and match. So many successful architectures are using serverless and maybe some containers, maybe using Fargate, so that you still don't have to manage them. And this mix is also a good way to learn and experience. And now with container image support, you can create container images that can be executed both inside a traditional container and also within Lambda. You just need to change a little bit the way they interact. But
yeah, that will bring a lot of new. Yeah, that will bring a lot of new possibilities of mixing architectures with this Lambda with container thing. So that will be awesome to have to build new architectures and mixing and all this stuff. That will be great. So great, Danilo. I hope you have a good time. I love your presentation. I hope everyone on the chat also are just excited as I am that you can share with us your expertise, Danilo. Thank you very much. And the AWS User Group Peru are very pleased. We are very pleased of having you here, Danilo. So thank you.
It's been really my pleasure.
Thank you very much. I hope you. I hope this is not the last time that we see you here in this community. So this is the first time, but hope this 2021 bring us new opportunities with you all.
Definitely.
Thank you very much, Anele. Have a nice day.
Bye. Cheers. Bye.
Bye.